Hi, everyone. Thanks all for coming here. So may I ask you a question? Does anybody here knows me? No one? Did any of you ever hear my name before? No. Well, that's embarrassing. But that's actually fine because even my teammates, my colleagues, they don't call me by the name. They don't call me Alon. They all call me the Jinx. Well, I kind of earned this name flat and square because every time I was on call, there was an incident. The system crashes. And when I say every time I was on call, there was an incident, I literally mean it. Every fucking time I was on call, there was a fucking incident. And if you don't believe me, well, I have proofs for that. I have some evidence. So I'm a millennial, I like to take selfies. So this is just another day at work, another day, another incident. Another time I went to have some lunch with friends. In the middle of lunch, another incident. I had to stop in the middle. It's really annoying. Another day commuting to work with a really bad signal in the train. Another incident. And even when I went to a vacation, having some beers on the beach, another incident I have to take care of. And if there's one thing you should take from this talk, do not drink and debug. Really, it never ends well. And also, I really like online gaming. I play EA Sports football, if you know that. And you can play, like, if you go, you have an incident, you stop in the middle, you lose. So all these incidents, really, my life was really stressful. It was really hard. So there's a problem, right? Every time I was on call, there was an incident, so we had to solve it some way. And the easiest way, let's go to our on-call rotation, and we just remove me from the on-call rotation, and everything is now solved, right? When I'm not there, there are no incidents. So the next thing we will do is celebrating. We like all the team. We went having some shots, some beers, celebrating the huge success that we had. So that's all we need to know, right? We had this problem, we solved it, and we went celebrating. That's all. Thank you very much. Any questions? No, not really. Even when I wasn't on call, the problems didn't stop, right? When other people were there, we still had many problems because I wasn't the problem. The problem was us, our team, our service, our product. Well, when I say us, our team, our product, probably ask yourself, who are we? Who am I? So, as I said, my name is Alon Kiriati. You can call me the Jinx if you want. I work for the issues team in ACC. ACC stands for Autodesk, which is the company I work for, construction, which is the industry, and cloud is cloud. We all know what cloud is. So ACC is pretty like a huge platform with like many things and workflows and so on. So I guess like it might take me hours to just talk about it. So I just went to Claude and asked them, what's ACC in 10 words? I really like the answer because it's really like summarizes everything. It's a unified platform that connects teams, data, and workflows for efficient construction project management. So if the ACC, the platform we're working on, is the construction project management, then issues must be like the Jira, right? Like we all have QAs, so also in the construction industry, people are checking the places and they have some like bugs or some things that are broken and so on. So in our product, they can actually file the problem that we find. This is how it looks like. They can assign it to the people who can fix it. They can also put some due dates and really like Jira for construction. And also probably the killer feature for us is also connected to actual modules. You have like 2D or 3D if you heard about AutoCAD, Revit. You can actually see the issue inside the module. So I'm working for the backend for this team. And obviously, as I said, I wasn't the problem, so we had to rethink the whole problem again and understand how we solve that so system won't crash again. Well, but before we solve it, we first need to understand and define the problem, right? So we define the problems. We have like 3 root causes that cause these like system crashes. The first one is we had too many major bugs that were deployed to production. Then, when they were deployed, it took us too much time to find the problem. Many times, our customers found the problems before we did. And even when we understood the problem, it took us too much time to actually get to a resolution. Right? So with these 3 problems, we can now continue and try to find like a solution. But before we find a solution, we first want to set a target, right? Because if we just like work forever for a solution, we can always improve, but we want to set the targets first. So we decided to set the KPIs to solve this problem. So our KPIs at the time, it was a few months ago, we want to be 9.5 availability uptime. Again, it depends on your industry or where you are today, but we decided that we want 9.5 availability time. Also, we want less than 3 incidents in 6 months. Our MTTR, mean time to resolution, meaning the time that it takes you starting when you find the problem until you actually solve it, we decided that it's going to be like 30 minutes. Many of these KPIs came from higher like the organization, and we want 70% of the bugs to be detected by automation before it actually arrives to production or to the customers. Right, so once we set the KPIs, we can actually now talk about the solution. So we identified 4 aspects where we can improve. Discover, the way we discover problems. Then the way once we discover them, the way we analyze the problems. Then how we recover when there are problems. And evolving over time, we want to improve all the time. So with these 4 domains, let's now deep dive into each one of them. The first one is discoverability, the way we actually discover the problems. Now, we took 2 approaches. The first one was shift left. Shift left, meaning that you have this kind of like pipeline, starting from design, pre-production, production, and until it goes to the customer. So in this kind of pipeline, what shift left means is you actually push everything to the left, right? You start like whenever you have some tests, think about go to your like kind of pipeline and think, can I do this test 1 step earlier, right? You want to push everything to the left so you can find the problems much earlier. In our example, what we did, for example, we had in production, we did some manual tests. We stopped doing this manual test in production. We want to find it before, so we did in stage canary tests, right? Canary test is where you split the traffic, and you can check before you deploy something. It's one example. Another example, we did some visual tests. We used the test team IO, but you can use Capybara, Selenium, whatever it is. We decided not to do it anymore and replace it with service integration tests. When we check, we spin up all the services, and we check the connection between all the services. Another thing we did in developments, once somebody deployed something to the dev environment, they went and checked the feature that they deployed or the bug that they fixed. We don't trust that anymore. Instead, we do all the tests locally. We do some API tests with some mocking with knock. So all the HTTP requests that we do it with knock. Right, so we actually pushed everything. We looked on every test that we have, and we asked ourselves, can we do it in a more stable way and earlier? We want to find problems earlier. The next thing we did is shift right. Well, when I first heard about shift right, I thought, well, I do understand what shift left is, but is shift right the opposite? Like, why would we want to push everything to the right? Like, you want to find problems earlier, not later. Well, shift right is not the opposite of shift left. It's a complementary, right? Shift right, it doesn't mean that you want to push things to the right in the pipeline, but it does mean that you do understand that something, even when you have all the tests in the world, they might arrive to production. They might hit production. And when they do, you want to find them earlier. So shift right means you look on the last link on this chain, and it's production, and you see if there you can find the problems earlier. So some examples for what we did. So we used to look on the logs every day. The on-call used to, in the morning, look on like a long list of logs and exceptions and all the errors. And that wasn't good enough for us because it means that it might take you 24 hours until you actually understand the problem. And also, you might miss some problems, or you might fix the wrong things. So we replaced all these logs. We don't do it anymore. We replaced them with alerts, so real-time alerts, so we can find the problem and know when it happened just in time. Also, we had some low availability and latency, which was reported by our customers. Again, we don't want our customers to report on anything. We do manage SLO. We decided the SLO, and we're monitoring all the time. We have monitoring all the time. Also, we try to reduce the number of bugs by doing some service reviews. Again, we look for the 400, the 500, all the errors, or things that might produce bugs. Right? So we did the left approach, shifting everything to the left, and also the right approach, once things arrive to production, once errors arrive to production, we want to find them early. Cool, so that's for discover. Now let's talk about analyze. Once you discover things, how do you analyze them? Well, the first thing is know your tools. Now, OpenTelemetry, and probably every tool that you use, from New Relic, Datadog, Dynatrace, whatever you use, you have these three domains that you can use them, right? The logs, the monitoring and tracing. And if you only use one of them, many people like to use logs for everything, also for monitoring, for tracing. You probably need to also explore and see if you could use the other tools that might suit you better when you have some problem, right? Tracing is like the best when you have some performance issues. Monitoring can be really helpful when you want to find some spikes, some trends. Logs is also good, but if you're using only one of them, you might want to explore the other tools and not be bound only to one tool. The other thing is also knowing your team. And by knowing your team, you know their names, you know what they're doing, you know what their strengths. But what I mean is, well, probably all of you, are there any senior engineers or more staff engineers, principal? Any junior engineers here? Cool, not many. So most of you, almost everyone here, is a senior engineer. It's like your trillion shift doing this on-call, and the time is really good now, right? It's like 9:30, so in the morning, we are all awake, our minds work pretty well. So it's really good time to talk about on-call. But, anything that can go wrong will at the worst possible moment. That's like Murphy's Law. So when there's going to be an incident, it's not going to be you. It's going to be your most junior engineer in the team. It's going to be their first shift, and it's going to happen at 2 a.m. in the morning. It's going to happen for the worst man you can think about and at the worst time. So when you think about the experience, try to think not if you can handle this kind of incident in the best time, but if this junior engineer in their first shift, if they can handle it in the middle of the night. So what we do that can help us is first thing is we have one-stop shop for everything. We have a lot of links. We use Slack, GitHub, all the tools. We use Splunk and all the graphs. So we have everything, one page, one wiki for all the things we need. We also have it multiple regions. We have 10 regions and multiple products, multiple services. So it's really a huge link of lists where you can find everything, huge list of links where you can find everything easily. So this is something that really helped us. We have all the data, the links you need in one place. Another thing that helped us is writing playbook for every alert. Right? So in this example, we have, for example, high CPU utilization. And then the next question you want to ask in your playbook is, why did this happen? In this example, CPU is above 80%, for example, for some time, for an hour. Then, OK, it happened. What should you do next? So there's a deeper diagnosis of how you can understand better the alert with some links and some graphs. In this example, check which component caused it and if it's flat or spikes. Then, OK, you have some more info about how you diagnose it. So next thing is how we resolve it or previous problem that we had. So in this example, there is some link for a web server, for a worker, with everything you need to do to solve the problem. And also known issues. Now, again, you can use whatever you want for the playbooks, but I think this template is really good. The why, the diagnose, resolved, and known issue that we know about, and open tickets. Cool. What we also do as I said, it might be your first, you know how to handle everything, and you have all the context probably, but think about somebody who's more junior or is just starting to do their first shifts in the on-call rotation. So the first thing we do is making sure that they have access to everything. This sounds trivial maybe, but believe me, it's not. You don't want your on-call to just realize they don't have the access to the database or some tools. when something happened. You want to find it before that. So making sure that your new on-calls, the onboarding on-calls, have the access to everything is really important. Also, they have the knowledge, and they have enough knowledge to handle problems when they are. The next thing we do is simulation. We took like 2 to 3 cases. Maybe you can even do some mocks or break something in your database in development, and then you give them to solve it with really minimal guidance. Don't tell them or give them hints. You want them to try to play with the tools. Give them enough time so they can actually play, understand what they have and what they don't. Also, it's fine. I like to put them a little under pressure so they can feel how it is. We want to make like a simulation. So it's fine to put them a little under some pressure. We also do some shadows. So the first time there's an on-call, they will join somebody who is more senior than them, see how they handle problems and what they do in their daily routine. And the next time when they are on calls, you can join them and help them if they have some problems. Cool, so that's for analyze. So we discover the problem. Now we understand what the problem is. The next thing is to recover. So what we learned as kids, right? If it's broken, fix it, right? If something is broken, just fix it. If it's your heart, your window, your car, whatever it is, just fix it. But the problem with fixing when you're an on-call or when there's an incident is that you're under a lot of pressure. I can tell you my own story. I used to work for a really big known company in the past, not this one. And I woke up, I think it was midnight, somebody called me, I got this pager, and they told me, okay, they were a core service, and they told me, you're overloading our service, the CPU here is more than 60%, solve it immediately. Okay, I got this call. I was really under pressure. They told me, solve it immediately. I know that this is a core service in our product. So I just, I knew what I was doing. It was some kind of quota algorithm that I needed to write. I wrote really fast. I just woke up. I just, called another guy from my team, asked him to do, a real, I told them, we don't have a lot of time for a code review. Just give me a stamp here and know what I'm doing. Tested it really fast. And I skipped some of the, some of the steps in the tests. And it wasn't a good idea. When this was deployed, I did test all the websites and also clients, but some of the clients were already up, and more than a million clients just crashed. It started as a Sev 3. We had Sev 0 is the worst severity. Sev 3 is okay. It's something you need to handle immediately. It's not that bad. So it started as Sev 3. When I deployed my fix, immediately it became it became a Sev 0. Because all the clients crashed, so it was a huge disaster. It started something bad, and it turned out to be a huge disaster. And obviously, the problem when you try to forward fix something is that you introduce a new state, right? Something in the very first version, it used to work. Then you deployed something. Now it doesn't work anymore. It's not good. So if you forward fix something and try to deploy a fix, does it work? Maybe. You hope it does work, but you don't know for 100%, right? So what you usually do before you deploy something new, before you're getting into a new state, is you fix it, then you test it, then you code review it, you do maybe some canary, and you do some gradual deploy, right? You open maybe a feature flag for 10, 50%. You do it really slow, and you want to make sure you're safe. And the problem when you try to solve something, fix it under an incident, is you don't have all the time in the world. So you need to skip some tests maybe, or write just one test and not many tests as you might wrote. You also need to, you don't have all the time for a really good and deep code review. Also, obviously, you can't do canary. You need to deploy something fast, and you can do gradual deploy. So you need to compromise on something, either the time it takes to fix something, or you might take a huge risk. And this is why we should stop talking about fixing things. We don't want to fix something if it's broken. We want to stop the bleeding. We want to make sure that the system is up again, even if whatever it takes you to do that. Even if you need to take down a feature, even if you need to reboot the system every few hours, whatever it takes to make sure the system is up again. Right? You don't want to fix. Maybe you don't want to fix it if you can't. Just make sure the system runs again correctly. And as I said, like when something is broken, like a car, your heart, a window, whatever it is, like in the physical world, you can't go back in time, right? But we developers, we are privileged. If we destroy something, if we crash something, we can go back in time, right? So it's time to talk about, instead of moving forward, like a forward fix, we should move in reverse. And we have some method to moving in reverse, moving back in time instead of like moving forward, right? So we don't need we want to prevent this new state. If something worked in some version, then it doesn't, then we want to go back to that version. So let me ask you a question. What's like the IT department cure for bad signal, malfunctioning coffee machine, or word piece? If you ever call like your IT or any customer service, what will they always tell you with any problem? Exactly. Like, have you tried turning it off and on again, right? This fixes almost everything, right? Because if you restart a server, clients, cache servers, because this actually, it means that you go back in time when the system starts, and you know that it worked, right? You know that it worked because it happened, and also you have a lot of tests when things are spin up. So you know that something used to work, you reboot many things that you can restart, and it works again. It can solve some RAM issues, some state problems, any vault or data corruptions, like caches. Obviously, it doesn't fix everything, and it might take down some resources for some time. Right? So there are some caveats, but it might fix a lot of things. So reboot might be your first solution before you try to fix anything. Then restore also, once reboot doesn't work, you can try to restore either database configuration. If you configured something that didn't work, try to reconfigure it again. And feature flags also are really helpful, right? If you open the feature flag, we cover all the new code or all the risky new code with feature flags. So if something goes wrong, we can just open and close the feature flags. Right? It's a way to restore back to things that used to work. Obviously, this can fix some data corruptions, misconfiguration, or some bugs covered by feature flags. It might be dangerous and will require some analyze, right? Before you can do this, you want to make sure what you're doing, and you need to understand the problem. So another solution that can be helpful is rolling back, right? You take a deployment, and you roll it back to a version that worked before. So any bug that is introduced, you can now fix it, and without even thinking. When we have a problem now, we don't need to analyze and understand what the problem is. If there's a problem after a deployment, we're just rolling back to the version that used to work. And this, obviously some caveats, it means that your CI/CD needs to support rollbacks. Also, it might roll back some Git commits. We commit weekly, so if we roll back, it means that all the good commits are going to also to be rolled back. And also, you need to be backward compatible, right? If you introduce, for example, a new API, nobody can use it until you have like 2 or more deploys, because this can be rolled back. So you need to make sure, this is probably the hardest part, is to be backward compatible. So that's for rolling back. And if you want to do some partial rollback is reverting, you find the offending PR, you revert it, and then you forward fix again. But you don't fix a problem, you just find the PR, you don't try to fix it, you just revert it, and you deploy again. This obviously takes some more time than a rollback because you actually need to find the offending PR, and if there is anything depending on this PR, it might break. Cool, so we talked about the I can call it the 4 R's before you move to forward fix, the reboot, the restore, the rollback, and revert. So hopefully you don't need to use the F word anymore. You have enough of R words, things you can reverse before you move forward. And this is what you try to do when we have an incident. So we talked about discovering issues, we talked about analyzing them, then recovery. So let's talk about how we actually improve all the time. We want to make sure we are improving. So it's important to say that this is not a one-shot, right? You don't, just like something you check from your checklist, we have discoverability, we have analyze, we have rollback. It's not something like that. You need to maintain it all the time. Right? So the first thing, it's like going to the gym, right? If you go to the gym for a year and then you stop, you're going to lose everything, all your hard work. You need to make sure you maintain it all the time to still stay in shape. The first thing is you need to update your documentation, and it's going to pile up. You have all the expectations, the playbooks, the onboarding, the links, everything we talked about till now. You need to make sure you put enough efforts to maintain it. Because, right, what's like worse than no docs? Outdated docs. Because, right, you actually rely on something that doesn't work, which is much worse. If you know that there's no like documentation, just go and figure it out. But if you rely on something that doesn't work, it's much worse. So just like I get some researches that I found in a Stack Overflow, so the average time that's spent on searching for answers, as we say, like the MTTR, for our case, we want to be like less than 30 minutes. So we want to find answers to problems we have really quickly. And apparently, only 10% of the developers find their answers in less than 15 minutes. Right? For most of the cases, it takes much more time to find answers, so we want to be really on this. Cool. So let's talk about also fine-tuning alerts. Yeah, you probably all know the story of the boy who cried a wolf, right? It's like false alarms are not something new. We are like people are handling them like for 25 centuries at least. This story about a boy, I guess you all know it. So there's like a town with many ships. Then there's a boy who tried to fool like the whole town, so they shout out, "There's a wolf here." Now the whole town wakes up. They're trying to protect their ships, but nobody's coming. And then he did it again and again and again until the fifth time a real wolf came, and the town didn't believe him anymore, right? So the wolf ate the ships and the boy maybe. Depends on which story you read. And the moral of the story is nobody believes a liar even when they're telling the truth, right? This is also true for alerts, right? Because the majority of alerts, this is according to researchers by Oracle Security, they found out that 40% of the people say that the majority, most of the alerts they have are actually false. That's a huge number. And also, they found out that 64% of the people, of the developers, security developers, find out that less than 10% of the issues were actually critical. Right? Like almost all the alerts were not critical at all. And this too leads to a situation where more than 70% of the developers say that they miss at least one alert. And this is not where we want to be, right? We don't want to miss really critical alerts. So good alerts need to have like 3 elements, right? First, they need to be actionable. Now, I see a lot of alerts I saw like in other companies when you get some information, that something, the system doesn't behave good, your dependency doesn't work, or things like that. Well, it's good to know, but I can't do anything about it. So I'm just like getting alerts all the time. If I can't do anything about it, then I don't want to wake in the middle of the night. Then also, it needs to be critical. You don't want to wake up for everything that happens, every bug, every 500 like error. You want to align your alerts to the SLO. If your SLO is not 100% probably, so if you decided it to be like 99.95, make sure that the alerts, this threshold, is also aligned to the SLO that you defined. And also, you want to be clear and contextual. Like when you wake up in the middle of the night, you want to understand the alert. What happened? Not just like a broad alert, something happened in the system, it crashes. You want to understand exactly why did you get this alert, and also hopefully you have some link to try to start and handle that. And this is where you stop. Like if you have alerts in your channel, I know of like Slack or PagerDuty, and you just ignore them, we should stop doing that because that will lead into the case when you have so many noisy channels and so many noisy alerts that you start ignoring them. So in our case, there are only 2 options. We never ignore alert, right? If it's a true alert, if something really happens, this is the best case, right? Because something really happens, so you go on and you fix the problem. If it's not, if it's a false alarm, you can fine-tune or remove the alert, right? If it's a known issue, for example, and you can't do anything about it, just remove it or put it in another channel. If it's something not critical, again, just like fine-tune and change the threshold. So in this case, when there's alert, you know for sure that something happened. And you never ignore all these known issues. Yeah, it's a low priority. You shouldn't do that. So we ask you a question like, what produces, we talked about a lot of improvements you can do, but what produces all this improvement? Where did they all start from? And probably a word that a lot of you will hate, some curse. And we talk about processes. Many people don't like processes. I think many times they can really help us to actually come with solutions to problems we find, right? Because they're not going out of the blue, right? So one thing that helped us is doing retros. We do it every 3 weeks, but you can do it obviously in your own cadence where people talk about the things that are good, and many times the things that are not good are things that you saw before, things that are broken, so we went and fixed it. A lot of these things came up from the retros and all this like stress that uncles have. Obviously, it doesn't have to be so like boring. There are a lot of templates you can find on the internet. Try to do it more like a kind of gamefully. We also do postmortem. So postmortem, unlike retros that we do in like a fixed cadence, postmortem is something that we do after an incident, right? When there's an incident, we ask first the 3 questions. We want to understand what really happened. Like what, the summary, the who was impacted, and the why. The 3 questions, what, who, and why. So let me give you just a snippet of code. So like one of the incidents we had, as you can see, it's like an async function, get data, then there's a fetch. And this actually lead to a crash in our system. Can anybody spot like why did it crash? Yeah. Actually, there's some there's a missing return, actually. There's the get data, and there's no returner. But if you think that the system crashed because there is a missing return, then it's going to turn into that. Because you're going to blame the developer who made up this code, right, who deployed this code. And then this developer is going to say, OK, maybe I was wrong, but what about the code reviewer? Why didn't they spot this problem? And the code reviewer is going to blame the QA. Why? OK. But why didn't the QA find this problem? And they're going to blame the product manager who's not putting in the requirements. So what we really want to do, we don't want to find like who to blame. We want to actually make it more blameless and focus on the process, right? This code was deployed, but it's not actually the root cause. Like there are many steps in the way we can find this problem, right? So instead of trying to find the code, because bad code will always be deployed, bugs will happen, people will make mistakes. So instead of focusing on the mistake itself, let's focus on the detection, right? First, how much time did it take us to detect the problem? Was it detected by our customers? Maybe we should add some tests. Why wasn't it tested? What about the alerts? Did we have alerts? Maybe we should add more alerts. Then the analysis, like how much time did it take to analyze the problem? What about the playbooks? Were they helpful? And the way we recovered it, right? So this is where a lot of like these initiatives come from all these like postmortems. Because when there's a problem and you don't focus like, yeah, there's a bug here, instead you focus on all the guidelines that you had in the middle and didn't help you. But then, as some developers said, yeah, we have like a lot of postmortems and retros. We have so many action items just like piling up, and maybe our grandchildren will fix them. We don't have the time to fix all like these kind of great action items, but we're just like a few people here. We can't fix all the problem that we have. So what we do, it's what we do to prioritize, and you can do everything that you want. And just like telling you about our story. So we started with KPIs, right? We have like every year, our team have like this round table. We sit together and we decide what we want to be our KPIs. So in this, just an example, it's not like real numbers. Let's say we have like SLO. We want to be like more than 3 nines. We want some latency, less than 2 seconds. And we want some MTTR, 75 minutes. And we set some goals. This is a current, and this is like the goal that we want to be. Right? Once we have the current and the goal, we check it every few months. And then there might be a hit or a miss. And then we have like a long list of all the initiatives and all the action items that we want to check, and we check them against the KPI. For example, somebody thought it might be a good idea to refactor the notification component. It's really a good idea, but it doesn't tie to any KPI, so it won't be like in the top list. Right? Then we go each one. For example, the reduced CD time, fix 500 errors. So all of these are tied to some KPIs we want to fix. And then, in this case, for example, we missed only the MTTR, so we want to start from that. Right? We first want to make sure that we hit every problem that we have, every KPI that we have. Cool. So back to August 2025, just a month ago. Wanted to check the results after all the hard work we've done here, and some jump. I'm not good at making these sounds, as you can see. So the results were pretty amazing. We had like this availability goal for 3 nines and a half, and we actually had like more than 4 nines. We had 0 incident in the last year. Our MTTR, since we don't use any more forward fix, only the going backwards, so we can fix everything in 20 minutes, actually, if it happens. We don't need to deploy anything forward. And also, the target was 70% to detect all the problems by automation, so we hit the 96%. So this time, we can celebrate for real the huge success that we had and all the achievement that we had. So, yeah, this is Daredevil. Now, he's here because it's time that we stop fearing changes. Like, it took us a lot of time, I might say it took us a lot of time, a lot of effort, and there were a lot of risk in the way. So it's time for stop fearing changes and start to dare. And by dare, I mean, look at the 4 aspects on your services and make sure that the discoverability is well defined as you want it to be. Ask yourself, well, do we discover things on time? And if there's anything I can improve, check every test that you have, see if you can shift it to the left, maybe find it earlier, and also when things hit production, make sure that you can find it as early as you can. For the analyze, again, take some time to maintain all the things that you need, and ask yourself the question, like, does everybody on my team know to analyze problem? Well, if the junior engineer, can they handle something in the middle of the night or not? For the recover, again, like stop trying to see if you can stop using the forward fix and instead replace them with recover, with going back in time, and again, evolve, make sure that you have enough processes to improve over time. And this will not only improve your service or your product, it will actually improve your whole work-life balance. When I came here, I was actually an on-call, and I asked a friend of my team, can you replace me? And they just tell me, yeah, it's like, this became like a no-brainer. Like, why not? Nothing really happens during our on-call shifts anyway. Not like before when it was really stressful. We have no incidents. We know how to handle all the alerts, so they just replaced me because, yeah, it's no-brainer actually. And obviously, I add also my time back at nights. I can eat better, less stressful, and I could go back to my hobby, which is online gaming. So yeah, finally I could achieve my real goal, which is make it to the first league and also winning the title. So for me, it was a bigger achievement than all the ones you saw before. Yeah, some applause here. Woo! Yeah, so I'd like to finish with the words of Jana Kingsford. She's an entrepreneur, and she said, the balance is not something you find, it's something you create, right? Most of you are senior engineers, so if you're stressful, you get some calls from some customers in the middle of the night, you're whining about, you need to work all the time, well, nobody will fix it for you. It's up to you to deploy enough guidelines and to make sure that your on-call rotation is healthy. Thank you so much.